Welcome to 7.1 Law of Sines. We are going to derive a different area formula that works for all triangles and doesn't require you to calculate the height. So we know that the area of a triangle is equal to 1/2 base times height. Recall that the base and the height must be perpendicular to each other. So if I consider my base to be little a, then my height will be perpendicular to BC, but going through A. I will now label side B and side C, opposite from angle B and angle C respectively. So now we have the area is 1/2. In this triangle, the base is A and the height is H. But sometimes we don't want to have to calculate the height. Let's now use trigonometry to find an alternate expression for the height. So off to the side, I could calculate the sine of C. That's opposite over hypotenuse, and if I'm using sine, I need a right triangle. So sine of C is opposite over hypotenuse, or H over B. Solving for H, I would multiply both sides by B. B sine C equals H. Now I'm going to put these two together. So I get that the area of any triangle will be 1/2 A, and H is B sine C. So this gives me the formula for any triangle. The area is 1/2 AB sine of C. If you look at the role of side A and B and angle C, notice it's two sides and the angle between them. So this formula really applies to any two sides and the angle between it. If we wrote 1/2 BC, notice angle A is the angle between B and C, so it would be 1/2 BC sine A. And lastly, we could have 1/2 AC and now sine of B. Another way to remember this is that whatever two sides you're using, the other letter will be used in the angle. So now let's go ahead and apply this. Example 4, find the area of triangle DEF if angle E measures 127 degrees and the known sides are D equals 12 feet and F equals 9 feet. You could always draw a triangle for this or just go straight to the formula where we have the area equals 1/2 two sides. Since we're given D and F, we need the third letter, so that's going to be E. We plug that into our calculator to get approximately 43. And because it's area, we need feet squared. Also, visually, just seeing this, I labeled F was, looking at the picture, you can also see that side F was 9, side D was 12, and angle E was 127. And notice it's two sides and the angle between them. So that is in fact the correct formula. So the area of DEF is 43 feet squared. Example 5, find the area of triangle ABC if B equals 58 degrees and 10 minutes, side A equals 32.5 centimeters, and angle C equals 73 degrees and 30 minutes. I personally like a triangle on this one because it's a little more complicated. Looking at this picture or at the given information, we can see that we do not have adequate information to find the area right now because we need two sides and the included angle, and we only are given one side. So therefore, we need to find either side B or side C. I will go ahead and find side C. One thing I want you to notice is that we now have degrees and minutes. In order to convert minutes into degrees, we can simply put into the calculator 73 plus 30 out of 60. But notice that 30 out of 60 is just a half. So C is also the same as 73.5 degrees. Now let's set this up. Using the law of sines, we will find side C. So C over sine C equals little a over sine A. But notice we don't even have angle A. However, we can calculate angle A because we know 2 of the 3 angles of the triangle. Let's go ahead and calculate angle A by hand. So we know that the 3 angles have to add up to 180 degrees. Off to the side, I will add the 2 angles that we are given. So the minutes add and we get 40 minutes, and now the degrees add. So we get 131 degrees and 40 minutes. So now we have A plus 131 degrees, 40 minutes equals 180 degrees. Now we will subtract the 131 degrees and 40 minutes from both sides. So notice we don't have any minutes to take away from. So we're going to borrow 1 degree. Now we're left with 179 degrees and we just got 60 minutes. So remember, 1 degree is 60 minutes. So 179 degrees and 60 minutes is the same as 180 degrees. Now we subtract. So A equals 48 degrees and 20 minutes. Now we are ready to use the law of sines. Once we find side C, then we will be ready to calculate the area. So back to little c, we're going to plug in the numbers that we know. So we get C over sine 73.5 degrees equals 32.5 over sine of 48 degrees 20 minutes. Because the C, or the variable, is on the top, I can simply multiply both sides by sine of 73.5. So now I will get 32.5 sine of 73.5 over sine of 48 degrees and 20 minutes. And this is right how I will enter it into the calculator. So my calculator is in degree mode. So therefore I will put 8 plus 20 divided by 60. The calculator, we now get approximately 41.7143 degrees, but we will keep that in the calculator to use in the area formula. So since I have side A and side C, I will now need to use the sine of B. So plugging in A, C, and B, I get 1/2 times 32.5 times 41.7, although we'll use the answer button on our calculator for accuracy, times sine of 58 plus 10 over 60, so that our angle is in degrees. Putting this in the calculator, we get approximately 576, but because our measurement is in centimeters, the area will be in centimeters squared. Notice this problem was a little more involved than example 4 because we did not have 2 sides and its included angle. So therefore we had to work using the law of sines to get a second side to be able to apply this area formula. I hope you enjoyed this video. See you next time.